Hello everyone, now we'll start with something called as a beta and a gamma function. Before going for beta and gamma function, we'll analyze the five types of functions which we have. One is the exponential function, which is e raised to x, a raised to x, log, algebraic, trigo, inverse, the ILET five functions which we have. The next what I'm interested in, if I see an exponential function, it is bound to give me a gamma function. If I see a log, exclusively log, gamma function exclusively algebraic, beta. Algebraic we here have considered x raised to m. Exclusively trigo, it will be sine, cos, that it is bound to give me a beta function. If it is inverse, sine inverse, cos inverse, etc., it is bound to give me a beta function. Now, the first part which we need to start with is a gamma function. Before starting with the gamma function, I should know that it is valid only for these two types of function. One is exponential and the other one is a log. The Basically, beta and gamma functions are used for simplifying the given integrals. Now, used for simplifying a given integral. So, first we'll start with the definition of a gamma function. So, what's a gamma function? Gamma function is basically, gamma and beta both are basically some improper integrals. So, what's the answer for a gamma function? It is integral 0 to infinity e raised to minus x, x raised to n dx. This is given by gamma n plus 1, the ulta L which we are writing. This notation is known as gamma. This notation is known as gamma. I'll repeat myself. What's a gamma function? It is of the form integral 0 to infinity e raised to minus x, x raised to n dx equal to gamma n plus 1. The most important thing which I should be interested here is this exponential term. Now in this exponential term, as you people can say, it is an exponential into algebraic. But I'll be interested only in the exponential term. In my exponential term, it should be e raised to minus x. It is e raised to minus x. In this e raised to minus x, whenever I have a gamma function or whenever I have an exponential or a log, I'll be interested in something called as a exponential term or the log term. I'll be interested here right now in the exponential term rather in being in algebraic. So exponential term it should be e raised to something. That e raised to something ka coefficient should be minus 1 and the power should be 1. I'll repeat myself. In exponential term, e raised to something, whatever is that something ka coefficient should be minus 1 and the power should be 1. I'll repeat, e raised to something ka coefficient should be minus 1 and the power should be 1. The most important thing that we should go for. Next, since we have five types of functions, we can have combinations of them. Now, what are the combinations? If I have an exponential into algebraic, it's bound to give me gamma. Next, if I have exclusively log, which I've already said, it's bound to give me gamma. Exclusively exponential is also bound to give me a gamma if it is something of the form. If it is something of the form log into algebraic, it is bound to give me a gamma function. Next, if it is only exclusively algebraic, I have already said it is bound to give me a beta function. If it is algebraic into trigo, it is bound to give me beta. Similarly, if it is algebraic into inverse may have taken into account sine inverse, cos inverse, it's bound to give me beta. So I know the functions which are going to give me a beta. One is purely algebraic, purely trigo, purely inverse, or algebraic into trigo, algebraic into inverse is bound to give me a beta function. Exponential into algebraic will give me a gamma. Log into algebraic will give me a gamma. Exclusively exponential also will give me gamma. Log also will give me a gamma. So the first problem that we'll start with today is something of the form integral 0 to infinity e raised to minus x raised to 4 into dx. Here, since it is of the form 0 to infinity e raised to minus x raised to 4 dx, this will be bound to give me a gamma function. Now, Whenever we start with the gamma function, I'll be interested only in the exponential term. So what is the exponential term over here? The exponential term over here is e raised to minus x raised to 4. The major important thing that we should remember in gamma function is e raised to something ka coefficient should be minus 1 and the power should be 1. The coefficient here is minus 1, but the power is not 1. So in this case, we'll go for a substitution. What's the substitution? Let x raised to 4 equal to t. As soon as I've written x raised to 4 equal to t, I'll write down it as x equal to t raised to 1 by 4. Why I've written x equal to t raised to 1 by 4? Because I'm interested in something called as a dx. What is my dx? 1 upon 4 t raised to 1 upon 4 minus 1 into dt, which is bound to give me a dx 1 upon 4 t raised to minus 3 upon 4 into dt. The next important thing is my limits. X ka limit is from 0 to infinity. When x is 0, obviously my t will be 0. When x is infinity, obviously my t also will be infinity. So the limits here are 0 to infinity. Next, the given integral becomes 0 to infinity e raised to minus t. What is my dx ka value? My dx ka value is 1 upon 4 t raised to minus 3 upon 4 into dt, which is nothing but 1 upon 4 is a constant outside 0 to infinity e raised to minus t raised to minus 3 by 4 into dt. The next, which will turn out to be 1 by 4. Now I'll compare my given function with the 0 to infinity e raised to minus x raised to n into dx gamma n plus 1. Whatever is my algebraic term ka power, that will give me the value of my n. So what is the algebraic term over here? The algebraic term over here is the t ka power, which is minus 3 by 4. So the answer turns out to be minus 3 by 4 plus 1, which in turn is going to give me 1 by 4 gamma 1 by 4. So if I see exclusively exponential, it's bound to give me a gamma. Product of exponential and algebraic is also going to give me a gamma. Log into algebraic gamma. Exclusively log also is going to give me a gamma function.